The eruption needs to be powerful enough to eject large amounts of material, and the ejected material needs to reach a height of over 12 miles above the Earth's surface. In the Philippines, in June 1991, Mount Pinatubo erupted. An estimated 20 million tons of sulfur dioxide and ash particles were blasted over 12 miles into the Earth's atmosphere. The blast was so powerful that the ejected material entered the Earth's lower stratosphere. Here, the ash particles spread out to form a thin cloud of debris. The cloud reflected some of the sun's radiation back into space. This resulted in less solar radiation reaching the Earth's surface, which caused a small drop in the Earth's temperature. Meanwhile, back in the stratosphere, the ejected sulfur dioxide was converted into tiny particles called sulfate aerosols. The sulfate aerosols reflected solar radiation back into space. So they too had a cooling effect on the Earth's temperature. But they also had another characteristic. They absorbed some of the infrared radiation emitted by the Earth. Usually, the greenhouse effect causes infrared radiation escaping from the Earth to be trapped and reflected back to the Earth. This results in an increase in temperature on the Earth's surface. But the sulfate aerosols absorbed some of the escaping infrared radiation, stopping it being reflected back to Earth. The result was a decrease in temperature on the Earth's surface. So a volcanic eruption can affect climate change by blocking out solar radiation and absorbing infrared radiation emitted by the Earth. It took over 2 years for the ash and sulfate particles to disperse from the stratosphere completely. Following the Mount Pinatubo eruption in June 1991, countries located in the Earth's northern hemisphere, like the UK, recorded lower than average temperatures in the summers of 1992 and 1993. In the summer of 1994, temperature levels were finally back to normal.